Hi everyone, I'm Liu. I'm physicist calling from Moscow.
Hi, everyone. My name is Kirill. I'm a data scientist and consultant, currently calling from Moscow as well.
Hi, everyone. I am Juaniko Moreno. I am a curator and researcher, currently calling from Bogota, Colombia. Thank you.
And hi, my name is Nicole Fitzgerald. I do fundamental machine learning research. I'm normally based out of Montreal, Canada, but I'm calling in today from Kalkan, Turkey. So a quick introduction for our project. I think it's one that revolves around the idea that planetary governance is implicitly oriented towards planetary life. And if we're to take the biological reality of this word life seriously, this isn't just a kind of governance that's about the management and movement of bodies, but the directed evolution of the biological fabric in which they're embedded. The last thing I'll say on this is this ability to direct life isn't just about the way that we interface with data and computation, even though they're key components of this larger picture, but also the way in which we interface with this big messy thing that is the biosphere. Thank you.
Yesterday's calamity is tomorrow's cataclysm. Crisis operates on the scale of the planetary. The speed and magnitude of the response must outstrip that of the crisis if it is to be prevented. Indeed, the response must precede the crisis, expressed not in the aftermath of destruction, but in the projective space of the model. The ability to sense, model, plan, and compose life, not just in real time, but in anticipation of real-time occurrence, manifests itself in the form of a positive biopolitics. It is a governance by composition, both for and of biological life. A governance whose logos rests not on institutional policy, but on the employment of multi-scalar, multimodal mechanisms of intervention, and whose ethos is grounded in a deep, unwavering commitment to planetary care. The project of a positive biopolitics is not one that asks us to choose between draconian measures of surveillance and control on the one hand, and stark libertarian individualism on the other, but instead renders the very premise of this dichotomy obsolete. It is a project built on the multiplicative imaging of the biosphere as a nested, entangled set of pieces and processes, revealing our condition as living matter, as organic material configured via organic code, as biological circuits and functions on each level of taxonomic abstraction, up into the space of cells and cellular metabolisms, to tissues and organs, species and genus, to the space of ecosystems, biomes, and planet. That which we can account for is that which we can compose. The proliferation of high-fidelity instrumentation has incited a data deluge of unprecedented resolution. DNA sequencers, mass spectrometers, electron microscopes, wildlife cameras, LiDAR scans, and satellite photography map the fleshy, living, pulsing terrain of organic matter through high-touch, high-proximity sampling and remote observation. The bio sees itself stitched up together across various spatial and temporal horizons to determine a new class of imagery, serving less as an alien motion picture than as a warped and fractured mirror. Push, pull, merge, fork, the usual operations of code-based management, must too come to bear on the design of open source, open access data flows. Mutual intelligibility across these flows, in the form of new protocols for labeling, storage, and verification, yields operability. Multiscalar indexing provides not a digital duplicate, but a method through which living matter knows and addresses itself. Computation is everywhere in the world, not just in the machinations of transistors and microprocessors. Life has been computing long before the age of the Anthropocene. Non-neural bioelectricity activates code stored in genes. Viral mutations update all species one generation at a time. Recent advances in computational modeling have provided the capacity not just to approximate and disclose these processes from data, but to generate and compose new points in data space, iteratively feeding back into the expanse of the archive. Nothing is so complex that it cannot be modeled and understood. Nothing is so sacred that it cannot be re-engineered and remade. In vivo, in vitro, in silico is the space of composability of the BIOS. But as information is mobilized from atoms to bits, bits too must find their way back to atoms. This mobilization will demand a host of new concepts, new institutional and industrial forms, and most importantly, a new mode of species-wide reflection and self-understanding. Peer into the kaleidoscope of DNA strands, single-cell diagrams, organelles and proteomes, lab samples of blood, spit, soil, and wastewater, microbial underworlds and molecular machinery rendered in vector fields, probability spaces, and gradient flows. And tell me, where are you? Our understanding of nature, technology, human, and the modes of governance they entail are lost and reclaimed 1,000 times over, giving way to a broader narrative of the BIOS as a medium and of evolutionary process as a vector of design. Thus, the ability to self-compose will appear in multiple guises. The manipulation and configuration of biological life, yielding new modes of treatment and prevention. The distribution and allocation of care in its many forms. And the directed coevolution of our species amongst many other species.